Hey everybody, this is Gregory from Dapp University, and in this video I'm going to show you how to take the ERC-20 token that we built in the previous episode with the OpenZeppelin library and deploy it to the blockchain, but also write tests against it. And that's kind of what I'm going to focus on in this episode is testing, and kind of show you some testing strategies that you can use for testing smart contracts. And this will be for the token, but it'll also be applicable to other smart contracts. So yeah, be sure to subscribe to the channel because we'll see how far we get today, and there might be more videos after this, and you don't want to miss those whenever they come out. And also be sure to check out that previous video in the series if you haven't already. So we left off with this token that we created, my token, a really basic token here, and we said this was a standard token, and it was a detailed ERC-20 token, which allowed us to specify some values here, like the name, the symbol, and the decimals, whenever we specified the constructor. So what we want to do now is take this contract that we successfully compiled at the end of the last video and deploy it to the blockchain to see if it works correctly. So what we want to do is create a migration script, and we can look in our migrations directory and create a new file here and call this deploy token.js. And we'll kind of go off of the other migration that exists to create our own. First, what we'll do is say, we'll just copy this. And we'll say, instead of saying migrations, we'll say my token. Oops. This is going to require the artifact, which is generated inside this build contract directory. This my token, where is it? mytoken.json, and we're going to assign it to a variable, and basically these are the exports. The default export of this file is going to be this function that deploys this contract to the blockchain inside the Truffle framework. So while we're here, we actually want to specify the constructor arguments inside this token, the name, the symbol, and the decimals. And we can do that by passing in more arguments into this deploy function like this. We'll pass in the name, symbol, and decimals. And these are just going to be variables that I'm going to declare here in a moment. I'm just using underscores as a style choice to kind of show these are the constructor arguments in Solidity. And so basically what I'll do is say const name equals my token. I'll say const symbol. Symbol equals mtk. And const decimals equals 18. All right. So now we have a deployment script that should deploy this contract to the blockchain. And now, in order to do that, we need to have a blockchain running. So first, we'll go to our terminal, minimize this, and we'll start a blockchain. So open a new tab, and I'm going to use Ganache CLI. So you might have seen my other tutorials where I use the Ganache, with the GUI, the nice, desktop application to use Ganache. And that's nice, but I'm going to also show you how to use Ganache CLI in case you haven't used it already. You can basically install it with npm, install Ganache CLI. I believe that's the correct way. I've already got it installed, so I'm not going to do that. Once you have it installed, you can basically just say Ganache CLI, I believe. And yeah, it'll go ahead and start a local in-memory blockchain, just like the other desktop version of Ganache would. And here are your available accounts. Here are the private keys for the accounts. Here's the mnemonic to restore this HD wallet. And the gas price, gas limit, things like that. Here's the port. So this is also really similar to Truffle Develop, if you've ever used that before. Whenever you run Truffle Develop, you'll see an output that's pretty similar to this. It's running Ganache under the hood, I believe. So yeah, now we've got a blockchain running on this port, an RPC instance on this port. So now what we want to do is connect our Truffle project to this. We'll go back to our project file, and we'll go to the Truffle.js file. This is where we specified the Solidity compiler earlier, and I actually did that in the Truffle-config file, which for me, I actually want to do this in Truffle.js because I'm on a Mac. If you're on Windows, you want to use Truffle-config.js because there's a conflict with the Truffle executable on Windows, and that's why they had to change the file name. So for me, I'm on a Mac. I'm going to use Truffle.js. Specify the Solidity compiler that we did in the last video, and now I'm going to specify the development network. I do that like this. I say networks, open this object and say development, and I'll say host. So be localhost, and I'll say port, and I believe our blockchain is running on 8545. Yeah, so just copy that, paste it here, and the network ID. Let's just say star. So that's going to match everything. All right, save that, and now let's actually try to migrate our contract that we created with this migration script to the blockchain. So now let's try to run these migrations in order to deploy this contract to the blockchain. We'll say truffle migrate. This will compile and deploy our contract with the migration script we just created. I'll just pass it the reset flag, be safe. All right. And it appears that the contract was successfully migrated and deployed to the network. So let's take this hash, let's just open the Truffle console, and let's see if we can interact with the token. We'll say Truffle console. All right. Now what we'll do is say my token dot deployed. Then we'll pass it a function, say instance. And let's say MTK, this is the symbol of the token, MTK equals instance. All right. Okay. All right. So we can see the address of the deployed token. This is the address on the blockchain. And we can see, all the functions that it responds to that we got for free whenever we created the OpenZeppelin token, or whenever we imported the OpenZeppelin library. We can see the, all the values here. We can see everything that it responds to, things like that. See the binary interface, the binary data. Yeah. So let's try to say mtk.name. Oops, sorry. mtk.name. All right, we can see my token. See mtk decimals. Okay. We see that's 18. And yeah, we could use, callbacks to coerce this to a number and things like that. But I just wanted to create a test to make sure that this is working properly. So now that's running. Let's actually try to write a test for this to see that our token kind of has the values that we expect. Let's actually write a test here inside of our directory. We'll go to the test directory, and let's just new file. I'll say test. We'll say my token .test.js. And now I'm going to write a test to ensure that this token kind of has the things that we specified whenever we deployed it. This will give you an idea of how to test your smart contracts. So let's go to, we'll start by basically saying, let's import the contract first. So we'll say const my token equals artifacts acquire. This is just like our deployment script. My token. All right. And now I'm going to use the Mocha testing framework and Chai assertion library that's bundled with Truffle to write some tests. I'll say contract my token. And I'm going to pass in the accounts. This accepts a callback function like this. And these are basically all the accounts in the network. So first, what I want to do is, describe the token attributes. And we'll say describe token attributes. And what I want to do is basically say this token has a name, and here what I'm going to do is actually use, well, before I get into that, let's just sketch out what we want to see first. We want to say that it has a name, and we want to say that, just say that it has a name, the symbol, and the decimals that we described. So I'm going to say it has the correct name, it has the correct symbol, and it has the correct decimals. Okay. Now, in order to test these things, we first need an instance of the contract to write tests against. And we pulled in the contract here, and now we want to basically interact with the deployed contract and read the values. So in our console, we got the token with my token.deployed. Sorry, let me find it. My token.deployed, and then we got an instance of the token. Now this is using promises in our console, which is nice. But what we want to do in our test is actually use the async await pattern. And if you're not familiar with that, it's basically a way of handling promises in JavaScript by waiting for the promise to resolve and assigning the result. Well, it's basically this is what it does. It waits for a promise to execute inside of an asynchronous function. And it waits for that promise to resolve before it continues executing any code. So I'll show you an example. So what we want to do is, Mocha allows you to create a function that's called before each. And this function is basically going to run anytime, or it's going to run before each example in your test suite here. So what we want to do before each, we want to actually deploy this contract, my token deployed. Well, actually, sorry, we want to say let's do it this way. We'll say my token.new. And we'll pass in all the values that were there. We'll say name. Sorry, I'm getting to the async await. I just want to get here first. Decimals. Let's actually specify those here. Say token. MTK. And then we'll say const decimals. All right. So basically, we're going to create a new contract and pass these values in here. And the reason I'm putting these values in variables here is that we're going to test against these values inside of these examples. So back to the async await pattern. Essentially, what we want to do is get an instance of this deployed contract. And we could, we want to wait for that to finish before these test examples run. So how we do that is we have to pass this a function first of all. Say function. Well, actually first, before we do that, I could pass this a callback function and then execute some sort of logic inside the callback function, or I could basically just do this, say await my token new, and I can assign, and what this does is that this is going to wait for this deployment to finish before it executes the next line of code, or before it actually finishes resolving this function. Now, async await inside JavaScript, you can only use a wait keyword inside of an asynchronous function. So we want to declare a function first of all. And we want to, sorry, that was confusing before I put that in there. We want to declare a function, and we want to specify that it's an async function. All right. So this allows us to use this await keyword, hence the async await pattern. And what we want to do is, we want to wait for this token to get deployed before we start executing these examples. And in addition to waiting, we also want to assign it. So we say this.token equals await myToken.new. And then, so basically this is going to wait for this token to get deployed to the blockchain and then assign it to this token, to this.token that we can read inside our examples. All right, so first, let's just run this test and make sure that everything is passing. I mean, there's nothing really to check against, but I just want to make sure that we did this correctly. So we'll say Truffle test. I probably forgot something, so we'll see. All right, no, I didn't forget anything. So, I mean, it says these tests are passing, but there's really nothing inside these examples. I just wanted to make sure that we kind of wired everything up correctly. So let's actually fill these in. So what I can do is, first one I want to do is pull in chai. I'll say require chai. And I'll say, let's do chai should. Okay. And essentially, so chai is just an assertion library that allows you to basically write assertions in your tests. So, Mocha is a testing framework, and chai allows you to do things like, say, assert. But what I'm going to do is actually use something called should. So that means I can take like a value and say value. I can chain this like this. Like value should equal, result. Right? I haven't declared these yet, but this is basically showing you that when I'm pulling in should, like this is what it allows me to do. So let's do that with a name. So I'm going to say, I'm going to get the token name, and, waiting for the token to get deployed is asynchronous, but also reading any of the values from the token is also asynchronous. So if I say this.token.name, if I want to store the value to this, I could, resolve the promise by, saying, .then, and then passing a function, yada, yada, yada. But instead, I'm going to use this async await pattern, much like we did in the before block, and say const name equals await this.token.name. All right. And in order to use await, we have to declare this asynchronous. All right. And now I'm going to use this should matcher and say name should and equal. I'm going to say name. Oops. Which comes from here. So I'm getting the name of the token read from the blockchain asynchronously, but I'm waiting for this to finish before I check the name. And then once this is done, I'm going to take the name that we stored here and say it should, should equal the name that we provided in our variable that was passed into the contract when it was deployed. So let's run that test. Let's actually comment these out for now. We want our test to be accurate. We want to say that we actually have one test and that it's passing. Well, let's make it fail first. Let's say it's equal to foobar. Let's say Truffle test. Uh-oh. All right, so it could not find chai. So what I need to do is actually install chai, and I can do that like this. I'll go to my package.json file, and in the dev dependencies, I'm just going to paste in some other dependencies here. This is going to be, the chai, chai as promised, and chai big number. And these are going to be just things that we'll use to test the contracts. So I've imported those. I'm going to say npm install. All right. And now I'm going to go back to my test and, sorry. All right, everything looks good. Let's run the test again. The Truffle test, we should have one example, and it should be failing because we checked against foobar. All right, so that's what we hope to see. We got a failing test. Now let's make it pass. So we'll go back and say this is name. Let's run it again. All right, and it passes. So we can check the same thing against these other values. We can say, well, it's not just copy and paste. Let's do it again. It has a correct symbol. We can say const symbol equals await this dot token symbol. And we'll say symbol should equal symbol. That's the symbol here. The Truffle test. So I also forgot to declare this asynchronous. All right. Okay, it's passing. Now the next thing we want to do is say that it has the correct decimals. So we say async function. We'll say const symbol equals await. Const decimals. Wait this dot token decimals. All right, now what I'm going to do is show you how to do this. So say decimals should equal decimals. And this is actually not going to work. It's going to fail, and I'll show you why, and then I'll show you the correct way to do it. All right. Well, actually, first of all, I spelled this wrong. That's not what I meant to do. Okay, so expected this to equal 18, and that didn't happen. And that's because, whenever we return unsigned integers of 256 from Solidity, JavaScript, returns big numbers. So basically, we need to coerce the big number into something that we can read and check against in our test. And if you look a second ago, we just installed this thing called chai big number, and that's exactly what we can use in order to check the big number that's returned from the blockchain. So I'm going to pull in the big number library like this. I'll say use, let's say require chai big number. And I'm going to actually call this. Okay. This is basically going to use big number from chai big number. All right. So now what we can do is say decimals should be big number. Big number equal to decimals. And that will compare this big number in a way that asserts that it's equal to this integer value here. So let's save that, and we'll run the test again. Oh, looks like I had a problem here. So big number is not defined. Yeah, it's my fault. I meant to assign this to the Web3 big number, sorry. So const, at the top of our file will say big number. Forgot to do this. This is a pattern that I've used in my other tests, and I just forgot to set this part up. So Web3 is provided, and say big number. All right, so Web3 big number is equal to big number. Yeah, that's what we're going to do here. Sorry. So let's run that test again. All right, now it's passing. So we've compared the decimal value to the decimals here. Okay, so that's how you create an ERC-20 token, ERC-20 Ethereum token with the OpenZeppelin Solidity library. That's how you deploy it to the blockchain, and that's how you write test against it with Truffle, with Mocha testing framework, and these chai assertions that we pulled in. So that should get you started building your own ERC-20 token. There's lots of other things we could do. We could, do a lot of more behavior. If you're going to use this token and you want to sell it, you'd have to write a crowd sale. You'd have to find a way to distribute it, or you could airdrop it or something like that. You'd probably want to specify some more values, like the total supply. You'd want to specify a lot of different things. You can write custom behavior on your token. There's all kinds of things you can do when you're creating an ERC-20 token, as long as it's ERC-20 compatible, as long as it has the kind of functions that you need whenever you're developing an ERC-20 token. And that's exactly what the OpenZeppelin library gives you. And it gives you a secure way to do that, so that you're not just worried about the kind of code that you're writing. Is it going to be secure or not? And so, yeah, we can look at all the other types of tokens here. You can have a token that can be minted, a token that can be burned, a token that can be capped, a token that can be paused. So yeah, there's lots of stuff we could go over here, but hopefully this should get you started. So if you want to see more videos about building out Ethereum tokens, let me know down in the comment section below. If you want me to cover like what a mintable token is, if you want me to cover like what a pausable token is, or a standard ERC-20 token, things like that. Yeah, just let me know down in the comment section below. I might make more videos on that. And yeah, be sure to subscribe to the channel. And until next time, thanks for watching Dapp University.